Hey there, and welcome to This Explainer. Today, we're diving into something that's honestly the absolute bedrock of everything we build, integrate, and scale in the digital world. I'm talking about system architecture. Think about the most awe-inspiring skyscraper you've ever seen. It didn't just magically appear overnight, right? It started as a highly detailed, deeply considered blueprint. Well, in the realm of complex IT structures, system architecture is that vital blueprint. It's the master plan ensuring our digital structures don't just stand up, but actually thrive when the pressure's on.
So here's our agenda for today. Think of it as our very own blueprint for this session. We're going to cover the system blueprint, core architectural principles, 4 architectural views, common architectural styles, and finally, why architecture matters. Let's get right to it.
Section 1. The System Blueprint.
Now, we know every great structure begins with a foundational plan. But in the invisible world of software, it's surprisingly easy to skip this step and just start pouring concrete. So what actually happens when you build without a blueprint? Well, imagine handing 100 construction workers a massive pile of steel and wiring and just saying, hey, go build a tower. It's basically a surefire way to engineer your own disaster. To really get why that's a disaster, we have to look at what architecture actually does. At its core, system architecture is the fundamental organization of a system. That means its components, their relationships, and the principles guiding its design and evolution. It's definitely not just a parts list. It's the master plan that wrangles massive IT complexity and, crucially, saves you from incredibly costly rework down the line.
Because without that clear vision, integration quickly turns into an absolute nightmare. We call it spaghetti code. You end up with these chaotic, point-to-point integrations where pulling on just one single string risks unraveling your entire application. Not exactly what you want when you're trying to scale, right?
Moving on to Section 2, Core Architectural Principles.
Okay, so if the architecture is the blueprint, then quality attributes are basically the rules of physics that keep the whole thing structurally sound. These are your non-functional requirements, things like modularity, scalability, reliability, security, maintainability, availability, performance, and usability. These are the pillars that make sure your app doesn't just spontaneously crash during a traffic spike or worse, expose sensitive data.
Let's pull out a couple of the real heavy hitters here. First up, modularity. Think of this kind of like building with Legos. You're breaking a massive system down into smaller, independent, self-contained modules. Why do we do this? Well, if you need to fix a bug, modularity ensures that changing one tiny piece doesn't cause the entire structure to collapse like a house of cards.
And then, of course, we have scalability. This is your system's ability to handle increasing workloads without missing a beat. Picture a massive Black Friday traffic surge. You can handle this by scaling horizontally, which is adding more machines, or vertically by adding more computing power. This is absolutely critical because it guarantees your system can grow right alongside your business without forcing you to do a complete ground-up redesign.
All right, Section 3. 4 architectural views.
Think about it like this. A physical skyscraper needs different blueprints for the plumbers, the electricians, and the interior designers, right? Well, a software system needs different perspectives too. To get a truly holistic understanding before any code is actually written, teams need to look through 4 distinct lenses. Step 1 is the logical view, or the what. Step 2 is the physical view, the where. Step 3 is development, focusing on the code. And step 4 is process, looking at the runtime.
By breaking it down like this, everyone gets exactly the context they need. The logical view serves the business analysts who really care about what the system does functionally. The physical view, that's for the system admins and network engineers figuring out where it actually runs on the hardware. Then you've got the development view, which helps software engineers organize their code packages. And finally, the process view is for performance engineers and integrators to understand how everything behaves at runtime. It just keeps everyone on the exact same page.
Let's jump into Section 4, Common Architectural Styles.
So, now that we know how to look at our blueprints, what kinds of structures are we actually building out there? Well, it's all about trade-offs. On one hand, you have the highly prevalent client-server model, which is great if you need centralized control. But if that doesn't fit the bill, you might lean towards a peer-to-peer network. That approach is entirely decentralized, making it incredibly robust, since there's literally no single point of failure.
Or perhaps your enterprise needs something a bit more structured. Enter layered or N-tier architecture. This style essentially stacks functionality like floors in a building. Up at the very top, you have your presentation layer, which is your user interface. Then you step down into the application layer for business logic, then data access, and finally the data layer itself down at the foundation. This setup is awesome because it promotes high cohesion and loose coupling. Basically, you can completely renovate the UI floor without having to tear up your database foundation.
All right, here is the ultimate structural showdown in modern IT right now. Monolithic versus microservices. The traditional monolith is built as a single unit. It's super simple to start with, but notoriously painful to scale later on. Contrast that with microservices, pretty much the standard for modern tech giants today. It breaks the application down into independent services. This offers massive scalability, sure, but you have to keep in mind it introduces a pretty steep cost when it comes to operational complexity.
Now, what if your specific scenario demands intense, real-time responsiveness? I'm talking like an e-commerce checkout on launch day. For that, you'd probably employ an event-driven architecture. Here, loosely coupled components communicate instantly by publishing and subscribing to real-time events via a message queue. It's incredibly fast. Similarly, you've got service-oriented architecture, which exposes functionalities as reusable services to really maximize interoperability across your systems.
Which brings us to our final part, Section 5, Why Architecture Matters.
So, we've covered the core principles, the views, and the different styles. But what's the actual so what here? What is the real-world bottom-line impact? Listen, without a robust foundation, you aren't just making your developers' lives miserable, you're pretty much guaranteeing business failure. Poor architecture leads directly to chaotic integration, terrible performance under load, absolutely ballooning project costs, and a total inability to adapt to new tech down the road.
Ultimately, system architecture isn't just some dry technical prerequisite, it is the strategic foundation of your digital success. So I want to leave you with a question to really chew on. When you look at the applications driving your business today, is your system built to adapt or is it destined to break? Thanks so much for joining me on this explainer. I highly encourage you to go take a long, hard look at your own blueprints. Catch you next time.